On the board we have two matrices, matrix A and matrix B. Remember that a matrix is just an entity that stores information, multi-dimensional information even. Now, looking at these, they don't mean anything except for the fact they exist. Now, matrices have what we call an order. They have a width, Harrison, and they have a height. I'm going to call the width J, and I'm going to call the height I. Now, when we talk about the order of a matrix, we always go by the number of rows it has, by the number of columns. This is going to be, how many rows do we have here, Levi? 3. And how many columns do we have, please, Matilda? 2. So the order of this matrix is a 3 by 2. Whenever we read the element of a matrix, we always go by the row followed by the column. So this one over here is 2, 2. This one over here is 1, 3. No, I said that wrong. 3, 1. So I saw Levi shake his head at me. All right, now looking at this, what would the order of this matrix be?
1, 1. Oh no, 2, 2.
2, 2. Why?
Because it's 2 rows and 2 columns.
Yeah, it's always rows by columns. Rows, how many rows are there? How many columns are there? Does that make sense so far? So what we're really knuckling down on in this lesson is just the notation. We're not even really operating on these guys. Now, suppose we have a matrix. Describe the matrix. Change it to 3. All right. Suppose we want to describe the matrix A subscripted ij equals 2i plus j in matrix form, where matrix A ij is a 2 by 3 matrix. What this is asking is, if this was an equation that described all the elements or the values of the elements in a matrix, what would it look like? Well, breaking this down, Aij, what's the capital letter to little a?
Big A.
Big A. You can write it as Aij, or you can just call it big A. Usually if we're doing it on a computer, we'll do it in bold font as well. What is the order? It's a 2 by 3, so how many rows?
2,
How many columns?
3.
1, 2, 3. So we're going to get a 1, 1, a 2, 1, a 2, 1, a 2, 2, a 3, 1, a 3, 2. Sorry, yeah. As you can see, I'm a little bit rusty with these. Does that pattern check out?
You've got 2 A2 1s there.
Whereabouts?
A1 2 on the left.
Row 1, row 2, row 1,
Yeah, thank you.
column 2, row
Two,
2,
column two.
column 2, row 1, sorry, row 1,
Column 3.
column 3, row 2, column 3. There we go. Even teachers get these wrong.
What is in the example where you said 2 times 3, is that different to the one you just did?
2 by 3. So how many rows do you expect?
2 rows back
But
here.
is it different?
Rows by columns. How many rows do we have here?
3.
1, 2, 3. How many rows? Sorry, columns. 2. Rows 2. Columns 2. Does that make sense?
Yeah.
Yeah. So I guess based on the mistake I just made there, it's always rows by column, so perhaps read it out when you're doing it yourself. Otherwise you'll fall into the trap I just did. Be better than your teacher. Okay, next. We want to describe the actual values. We have a formula to change them into this form over here. Now the question is, how do we input it? Well, we're working with row 1, column 1. So when I put this in, it's going to be 2 times I plus j. What is I in this instance? 1. And j is 1. Formula again. What is our row? Our row is 2, so our I is 2. Our column is 1.
So J is 2.
Bingo.
J's in column 1. It's column 1.
That's a J, that's an I. This represents rows.
Rows. Yeah, it's 3 rows. He's going the first bit. It looks weird. He's got just 2 rows. Yeah. What column? 1, 2. And that's in column 1, so it's 1.
Is that okay so far?
Yeah.
He gets it. He was just confused.
Sorry, sir.
Ladies, is it okay so far?
You know, I thought that was first row middle.
Okay, we're at row 1 still. We're in column 2.
2.
What's
Yeah. Then 2, 2.
And then 2, 2.
2, 2, 2. Actually.
2, 2, 2. There's
Bingo.
and then,
How do you know?
yeah, 1, 3.
Okay.
1, 3.
And then 2, 2, 3.
2, 2, 3, yeah.
Yeah.
Okay, so 3. So, can you explain that again?
Okay, this is row 1, row 2,
I is 1.
column 3, column 3. And then all you need to do is compute. So this is 2 plus 1 is 3. 4 plus 1 is 5. 2 plus 2 is 4. 2 or 4 plus 2 is 6. 2 plus 3 is 7.
1, 2,
5.
and then plus 2.
And then this is 4 plus 3 is 7. So this is our matrix in its matrix form, as opposed to a formula form. I actually don't think there's a name for these. If there is, I don't know. But yeah, that's how it works. Are there any questions so far?
What is this actually showing? Like, what?
The reason why we're doing these exercises here is I want you to know the concept of order, and I want you to remember that we always scan the rows, then we scan the columns. If we do questions like this, it forces you to explicitly think about what your location is. Does that make sense?
A mean, like the big A.
The big A means that we're working in its matrix form.
So A means matrix.
Yeah, basically it's stating you don't have to use the capitals, but by convention, most of the books you read will use it in this form. So we just use the capitals to describe.
So it's like matrix 4 equals like.
Yeah, the matrix equals this form here.
Yeah.
This is like saying A equals 5, except rather than a scalar quantity, which is a just singular value, we're giving it big data. Cool? You've already sort of used these before. Do you remember when you did coordinate geometry and you're working with points? So like point 2, 1, so x equals 2, y equals 1. It's effectively working like a matrix because you've got two pieces of data. We call it an ordered pair. You can do matrix operations on that if you want. But yeah, this is just like an expansion of it massively. Seem cool? All right, so where this takes us, guys, is we are simply trying to become very familiar with the concept of matrix notation. That being order, that being knowing the position of each member of a matrix. We start off with simply writing the order or stating the order of these matrices. First one being 1 row and 5 columns. What's the order? Shot out of a cannon, Alyssa? 1 by 5. Or is it 1 by 4? Nice.
Wait, what is this 2 and 3?
You said 5 colours.
Whereabouts?
Just 2 by 3.
Maya, question?
No, I'm just...
Emma, questions?
No.
If you got questions, other people have questions.
Mm-hmm.
Do you have a question?
No, I don't know. I figured it out.
All right.
Another question.
Okay. This part over here, you're just replicating what you saw on the board over there. I won't hold you up to show you, but I'll show you on a calculator on the screen what you could do to make it more streamlined. Question 3. You're organizing a shopping list. Now, to do this, it could be actually, no, that's not going to work. I'll put an example on the board for that after. It's the sort of thing you don't need someone to explain it, you just need to visually see it. Similar with question 4. And then question 5. Notice that the system of equations, so these equations are written in general form. You would have done this when you did simultaneous last year. Have a look at how they're translated into a matrix. Now imagine that we had equations that not only had x and y, they had z and about 50 other coefficients or terms on it. Would they be easy to solve? Not really, unless you had them in matrix form and you fed them into a computer, in which case they become very easy.
Yeah.
All right. So you're going to convert these systems of equations into matrix form. Does that seem cool? So not a lot of work to do today. We'll do the first half of this lesson chugging through this, and then we'll spend the rest of the lesson just going through our investigations. Cool?
Yeah.
All right.